Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding the number of trailing zeros in a factorial. Let's look at the problem description. We are given an integer n and we have to return the number of trailing zeros in the n factorial. So the factorial is the product of all the numbers ranging from 1 to n. Let's take a look at the example 1. So here the value of n is 3 and the 3 factorial is 6. So there is no trailing 0. So that's why the output is 0. In the case of example 2, the value of n is 5. N factorial is 120. So it has one trailing 0. So the output is 1. In the example 3, the value of n is 0. 0 factorial is 1. So the output is 0. Because there is no trailing 0. That's why the output is 0. So the constraint for this problem are the value of n is ranging from 0 to 10,000. We are expected to come up with a logarithmic time complexity solution. Let's look at the approach to solve this problem. So we are given the input n with value 10 and the expected output is 2. As you all know, the factorial of a number is the product of all the numbers in the range 1 to n. So in this case 1 to 10. So we get 3,628,800. This number has 2 trailing zeros. So that's why the output is 2. So how can you find the number of trailing zeros? Basically, first compute the factorial of this number and then repeatedly divide that number by 10. And if the remainder is 0, then that means the last digit we have is 0. Then we can count that cases. So at the end we get the total number of trailing zeros. But this is a linear time complexity solution. So the factorial can also be defined as the product of the factors of all the numbers in the range 1 to n. For example, here the 10 is expanded to 2 times 5. 9 is expanded to 3 times 3 by its factors. 8 is expanded to 2 times 4. 6 is expanded to 2 times 3. 4 is expanded to 2 times 2. So if you see, this is the product of all the prime factors of these numbers. Okay. If the number ends with 0, then that number should be divisible by 10, which has the prime factor 2 and 5. Okay. So basically we need to find how many times the factor 5 occurred in this list of factors. For example, here we see 5 occurred once and here second time. So the output is 2. So we have 2 zeros. That check will work till the number has only one 5 in its factor. Okay, for example, the moment we reach 25, the 25 has 2 5s. To extend that solution, what we have to do is find the numbers which are of multiples of 5 in the range from 1 to n. Okay, once we find that list, then we need to find how many times those numbers can be divisible by 5. Then sum those values and then we can finally get the total number of zeros. For example, in this case 25 factorial, we need to multiply the numbers ranging from 1 to 25. So in that range we have 5, 10, 15, 20, 25 are all multiples of 5. Okay, then we divide these numbers, each numbers, by 5 repeatedly until that quotient becomes 0, and then sum all those count. For example, here we can divide this number by 5 once. Here we can divide the number by 5 once. Here we can divide the number by 5 once. Second time we have number 3 which cannot be divisible by 5. Okay, this number can be divided by 5 once and this number can be divided by 5 2 times, because the first time when we divide we get 5 as the quotient. We can again divide that 5 one more time. So repeatedly when we divide this number we can do 2 times. So 1 plus 1 plus 1 plus 1 4 plus 2 6. So we have 6 zeros here. This approach lead to a quadratic time complexity solution. Okay, but the requirement is we have to come up with a logarithmic time complexity solution. Okay, so we can achieve the same result by repeatedly divide the given input number n by 5, okay, until the value of n becomes 0, and then we add the quotient value to the count. Okay, for example, in this case 25 divided by 5, we get 5 as the quotient. We add that 5 to the count. Next we can divide that 5 by 5 again. So the quotient value is 1. So we add that quotient to the count will be 6. So that is the number of trailing zeros in the factorial of 25. So in this case, each iteration we divide the value of n by 5. So the time complexity of this solution will be log n base 5. Okay, so that's what I have written here. First we initialize the trailing zero count variable to 0. Then repeatedly divide the input number by 5 until that number becomes 0. So after dividing the number by 5, assign the result to the number. Basically we update the number and then we add the new value of the number to the trailing zero count. We repeat this until the number becomes 0. Then finally we return the trailing zero count. Let's look at the flow chart. Input for this procedure is n, and first we initialize the trailing zero count variable to 0. Then we enter this for loop. This will run until n becomes 0. Okay. First we check whether n is greater than 0. If that is true, we go ahead and divide that number by 5 and update the number. Then we add the new value of n to the trailing zero count. We repeat this until value of n becomes 0. Once it becomes 0, then we come out of the loop and then return the trailing zero count. Let's move on to coding. First I initialize the trailing zero count variable to 0. Then I write the for loop. This runs until the n becomes 0. Each iteration I divide the n by 5 and assign the quotient back to the variable n. Then I add the new value of n to the trailing zero count variable. Finally, I return the trailing zero count value. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. We are given the input n 30. So the 30 factorial has 7 trailing zeros. That's why the expected output is 7. So first we initialize the trailing zero count to 0 and then we enter the for loop. So when we enter, the value of n is 30 and trailing zero count is 0. First we divide the n by 5 and then assign the quotient to the n. So the value of n changed from 30 to 6. Then we add the new value of n to the trailing zero count. So the trailing zero count will become 6. Okay. In the iteration 1, again we divide the number n. We divide the 6 by 5. We get quotient 1 and then we assign that to n. So the variable value of n becomes 1. Then we add the new value of n to the trailing zero count. So the trailing zero count becomes 7. Okay. And then in the next iteration, value of the variable n is 1. So when we divide this by 5, So the value of n becomes 0. New value of n will be added to trailing 0 count. So it remains same 7. Okay. Because n is 0, we break out of this loop and then we come out and then we return the value in the trailing 0 count variable. So which is 7. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of log n. Okay. So let's take a look at the case where n is 30. So 30 is approximately equal to 5 square. Log n base 5 is 2. So in the previous code walkthrough we saw that when the input is 30 in 2 iteration we were able to find the number of trailing zeros. So the 2 is equal to log 30 base 5. In case 2 where n is 5, it is equal to 5 to the power 1. So in first iteration itself we could find the number of trailing zeros in the 5 factorial. Okay, so 1 is equal to log 5 base 5. So basically this for loop runs log 5 base 5 iterations. If the value of input is n, then this for loop runs log n base 5. That's why the time complexity is order of log n. Space complexity is order of 1 because we are not allocating any additional space. We just use only this variable. So that's why space complexity is order of 1. Thanks for watching this video. Have a great day.